Ladies and gentlemen, this is Mr. Green, and I wanted to give you a quick little review of Unit 2 before you go in to take the Unit 2 test. So I wanted to make certain that I was covering some things with you just because there's a lot of stuff in that unit. So this is my Unit 2 review slides that I've got prepared. First of all, we talked about rectangular prisms, and we talked about the surface area being 2 times the area of the base plus the lateral surface area. Now, B is the area of the base. When you're looking at these prisms, sometimes they're triangular bases, sometimes they're rectangular bases, sometimes they're square bases, and so forth. The base is one of the sets of sides that is the same on both ends. A lot of people tend to take the triangular ones and try to take one of the rectangles to be the base, and it can't be. If the triangles are the only shapes that are the same at both ends, then the triangles have to be the bases, and you have to find the area of the triangle. I know it's difficult, but that's what we got to do. Okay? The lateral surface area, the easy way to do this one, take the perimeter of the base times the height. That's the easy thing to do. The perimeter of the base times the height of the prism. Now, this height of prism is the distance between the two bases. So if it's a triangle, it's the distance between the two triangles. Okay? So, volume. We're talking about the area of the base again, that B, times the height. This is the height of the prism. Okay? Got it? Good. Rectangular prisms should be fairly simple for us. Pyramids get a little tougher because we only have one base on a pyramid, so the formula is slightly different. We use pyramid is the area of the base plus the lateral area. Now the base, okay, could be those same type of shapes again, so that one's fairly simple, but it's the L that is the confusing, the lateral surface area. Easy way to find this is to find the perimeter of the base times the slant height of the prism. Okay, slant height of the prism, that's the one that goes up the side, not the one that is one of the edges. It has to go up the side of the prism, of the pyramid, okay? And then you're going to just divide that whole thing by 2. The volume is 1/3 of the base times the height. So 1/3 of the area of the base times the height of the prism. Now this height of the prism is the altitude. This goes from that vertex, that very top point, down to the base, making a 90-degree angle with the base. Okay? So these are slightly different measurements that I should be able to figure out and should be able to remember from when we went through them in the unit. Okay? Cylinders. Cylinders are going back to prisms, a little bit easier. It's the surface area is 2 times the area of the base plus the lateral surface area. The base is a circle, and so we're just going to use the circle formula. Area of a circle, pi r squared. Okay? Lateral surface area. Easy way to find this. The circumference of the base. Well, that's still the perimeter of the base, just a circle version of it. So it's 2 pi r times the height of the prism. Well, it's a cylinder in this case. The height of that cylinder is the distance between the two circles. That's the way you find that. The volume, once again, pi r squared times h. H is the distance between the circles. Okay? Cool. Let's move forward. Cones. Cones are ones that have another one of those formulas that's hard to remember. Surface area. Area of the base plus the lateral surface area. Area of the base is a circle. Pi r squared. The lateral surface area. Easy way to find this. The circumference times the slant height of the cone times pi. That's the easy way to find it. The volume. 1/3 of the area of the base times the height. This is area of the base, circle again. Height is the altitude of the cone. It is not the slant height. It's not the one up the side of the cone. It is the one that goes from the vertex to the base, making a 90-degree angle. Okay? So let's move forward here just a little bit. We've covered all these. Spheres. Spheres are my favorite ones. Surface area, 4 pi r squared. That means 4 times the area of a circle. And if you know the radius, you can find the area of the circle and then take 4 times that, and you've got the surface area. Really simple to do. Volume, 4/3. I know that's a little bit weird fraction, but it's still one you can use. 4/3 pi times the radius cubed. Well, we're talking about volume, so cubing is not that unusual here. So it's just going to be to the third power for that radius. Okay? Cavalier's principle was talked about early in the unit. Okay? It's a if I've got two similar objects, okay, they don't even have to be the same types of objects. Okay? They just have to be similar type objects. Okay? Cross sections, like the bases, or two objects that have equal area, okay, and the heights are the same on them, then the volumes will be equal. If the heights aren't the same, they won't have the same volume. But if their heights are the same, they will have the same volume. Remember where I worked a problem in the class Connect where I had those two cylinders. The um, height on one of them was 10, but the height on the other one was 8 because it was leaning over the side. It had a 10 that ran through the middle of it. Well, that 10 wasn't the height, was it? It was just a slanted distance. And so we had to have that height of it, and it was 8. Those two volumes weren't the same because they weren't the same height, even though they had the same radius on them. That's what Cavalier's principle is telling you. Symmetry. Symmetry is where you take objects and you're trying to see if they're the same, if you folded them in half and things like that, obviously. But it also is dealing with the translation, the rotation, and the reflection. Why? Because those are when we actually take those objects and we create new objects with them. Okay? So we need to make certain we understand how to do the reflection, the rotation, and the translation of an object. Okay? But if you take a rectangular prism, is a rectangular prism one that we can divide in half and get it and make two more prisms out of it that are equal to each other? Depending upon how you slice it, typically through the middle of the sides, it would work, or through the diagonal of one of the bases all the way down. That would make would give you something that would you could say is similar, but it's something you have to look at it very carefully because if the base doesn't have symmetry, then the uh, prism wouldn't have symmetry as well. Pyramids, same sort of thing. Base doesn't have symmetry. It's going to be difficult to find something that you could slice it in half with. But one of the things you might look at there is if you go through the vertex and then go through the corners of the prisms, you might wind up with two prisms that are two pyramids that would be very, very, very similar in shape and would have symmetry then. Okay? But it's one of those things you got to be careful with. Cylinders, the bases almost always have symmetry because they're circles. So guess what? You can slice them in almost any direction and you would get a symmetry on that as long as you're going through the center of the base. And you could come up with something similar to that cylinder. Okay? Two half cylinders would be similar to each other. Now, if you tried to slice it the other way, you have to go through the midpoint of the height to be able to slice that cylinder into two equal cylinders. Cones, similar to cylinders, circles on the base, so as long as you're slicing the base through the center of the circle and you're going through the vertex on the cone, you would get similar cone or similar shapes out of it. Okay? But you got to be careful with it. Spheres, I don't care how you slice a sphere. If you go through the center of the sphere, it's going to be symmetrical to each other. Okay? So that's one of the easy ones that you can get there. Now, just a couple of things. What formula am I looking at right here? If I'm looking at 1/2 the base times the height, that is the area of a triangle. Okay? And these formulas are ones you should be familiar with. This one, 1/2 AP. This is the area of any polygon, any regular polygon. Regular polygon. And we typically use it with hexagons and pentagons and hexagons and octagons and things like that. This one down here, what is this the area of? It's a trapezoid. Okay? So, Some formulas that I thought you might ought to remember for area. Those are the ones that are the hard ones to remember, and people get confused on them all the time. So this is any regular polygon, octagon, hexagon. This is a triangle. Okay? This is a trapezoid. This one here, this one that's for any regular polygon, if you know the apothem, yeah, that's very similar to the center, from the center to the edge of the polygon. If you know that apothem, finding the perimeter sometimes is real easy, and you can take 1/2 that apothem times the perimeter and get the area of that polygon. Okay, part 2 of the test. You're going to have two types of questions. One of them is going to be reflecting across a plane and translating an object. Go look at the last Class Connect, because I went over this quite a bit in that Class Connect. We did quite a bit of this in there, okay? Translating an object. It's one of the things that you need to be able to do. This other one here is dimension changing scale factor, and I forgot to talk about that in that Class Connect. I needed to talk about that just a little bit. So what I wanted to do is I said I wanted to give you a couple of examples here. If you have a 2 by 3 by 10 prism, that means it's 2 in one dimension, 3 in another dimension, and 10 going up the other dimension. If you find the volume of that, it'd be 2 times 3 times 10, and you would get 60 cubic units. But if I took each one of these dimensions and I divided them by 3, okay, I'm dividing them by 3, making them 1/3 their normal size. That'd be 2/3 units long and 1 unit deep and 3 1/3 units high. Then the volume would be 2 2/9 units cubed. I mean, you can multiply it out and you'll get 2 2/9. If I divided 2 2/9 by 60, I get 1 over 27. This ratio is kind of important because it is actually 1 divided by 3 times 3 times 3. And what were we doing to begin with? We were dividing by 3. You notice how it's got 3 times in there. Interesting. Also, if I doubled each one of these original dimensions, so it becomes a 4 by 6 by 20, the volume becomes 480. And if I take 480 and divide it by 6, I get 8. And 8 is 2 times 2 times 2. And what were we doing? We were doubling. We multiplied each one of them by 2. So volume, 3 times. Interesting, interesting. Let's look at surface area. Do the same sort of thing. If we take a 6 by 10 by 10.5 prism, the surface area for that is 328. You can check me on that. You can multiply it out and see what you come up with. If I divide each one of those dimensions by 4, I've got a 6 over 4 by 10 over 4 by 6.5 over 4. I mean, that's not hard to do, divide by 4. If I find the surface area of this new prism right here, I'm going to get 20.5 units. That 20.5 divided by the original 328, I get 1 over 16, or 1 over 4 times 4. Surface area, 2 dimensions, 2 numbers. Interesting. If I increased each one by 10, I would get a 60 by 100 by 650, which is 32,800. 32,800 divided by 328 is 100, or 10 times 10. I was increasing by 10 and I multiplied it by 2. So red letters down here. Remember this. So if we change all 3 dimensions, we're changing all 3 dimensions by some factor, my surface area changes by that factor squared, and my volume by that factor cubed. See how we're doing this? Squared, squared, surface area, it's in square units, volume, cubed, cubed, and it's in cubic units. I think I see a pattern here. If I'm changing all 3 dimensions, I can do it that way. That's one of your part 2 questions. It really is. And I'm trying to give it to you. All you got to do is follow that trick that I'm showing you right here. Whatever factor you're doing it, square it for surface area, cube it for volume, and that's what your new one's going to be. That's interesting. Very interesting. We're going to get more into that in the next unit, but that is something that is introduced in the symmetry, and I just didn't remember to tell you about it, and I wanted to make certain I gave you that in this review. Okay, so I will not be there Thursday to do Class Connect. That's why I'm doing this right now so that you have this. And because the test is on Monday, I want to make certain I get it to you. If you have any questions, feel free to come to tutoring on Tuesday or Wednesday. Okay, and we'll try to get them worked out. You need to try to take that test as quickly as you can, though. I will talk to you next time.